Hey guys, this is homework 7.9 on simplifying complex fractions. So if you notice in example 1, we have like two fractions being added, and then we have a fraction being divided by that. So what I like to do here is I like to change first this fraction bar that you see. I like to rewrite this whole problem so that that fraction bar is not there, and we actually just use the division symbol instead. So that's the first thing I do. So the top is 1/9 plus 1/18. And then instead of the fraction bar, I'm going to use the division symbol, 1/3. And I want to make sure it's clear that all this stuff is being divided by 1/3, so I'll put that in parentheses just to be clear. So then that helps me kind of sort out what I need to sort out first before I do the division. So I need to take care of the 1/9 plus 1/18 before I do the division. So let's do that first. Okay, so 1/9 plus 1/18. Well, I need to get the denominators the same, and this one's pretty simple. I just multiply the 1/9 by 2 on the top and 2 on the bottom. And now that gives me 2/18 plus 1/18. And if I add that, I get 3/18. And actually, I can simplify this. I don't have to, but I can. It's easy enough to simplify it, so I will. If I divide the top and bottom by 3, I get 1/6. Okay, so this 1/6 is equivalent to that 1/9 plus 1/18. So I'm going to sub it back into my original problem, and I'm going to write 1/6 divided by 1/3. Okay, so now with division, like we mentioned earlier in a few lessons ago, I have to do keep, change, flip. But I can't do that until I have one fraction being divided by one other fraction, which is why I had to go through this whole process to get it. So I have one fraction here being divided by one fraction there. Now that it is like that, I can do the keep, change, flip. So I keep the first fraction the same, 1/6. I change the sign in the middle to multiplication, and then I flip the second fraction. So 3/1. Okay, and now I multiply right across. So 1 times 3 is 3, 6 times 1 is 6, and that leaves me with 1/2. Okay, so no variables, no polynomials in this, so it was pretty straightforward. So let's go to a second example. Okay, so in this example, now you see we have some variables involved. So first thing I'm going to do, like I mentioned in the last example, is I'm going to change this fraction bar to a division symbol. So I have 2/3 plus 2/x, and I'm going to put this whole thing in parentheses to show that, or to indicate that I'm dividing this whole thing by 5/3 plus 5/x. So I'm going to take care of what's inside the parentheses before I do anything. Okay, so first set of parentheses, 2/3 plus 2/x. I need to make the denominators the same. So the first denominator, 3, I need to multiply an x to it. And the second denominator, x, I need to multiply a 3. So here we go. So I have 2x over 3x plus 2 times 3 is 6 over 3x. Now, I keep saying this, like I said in the last video, but you're going to be really tempted to start crossing things out on the top and bottom of the numerator of each fraction. But remember why it's there in the first place. So for example, the x in the top and bottom of the first fraction, we don't want to cross those out because the reason it's there is so that the denominators are the same so we can actually add them. Okay, so let's go ahead and add them. So I have 2x plus 6. These are not like terms, so we get this binomial. And then the bottom is just 3x. Okay, so we are totally done with kind of like compressing or those two fractions into one. We're totally done with adding those two fractions. Now we just have one fraction. So now we have to do the same thing with the right side. So I have 5/3 plus 5/x. So again, it looks like our common denominator is 3x. So the 5 over x, I multiply top and bottom by 3, and the 5 over 3, I multiply the top and bottom by x. Okay, so I get 5x over 3x plus 15 over 3x. And then since the denominators are the same, I can combine the fractions. 5x plus 15 they are not like terms, so I have a polynomial or a binomial. Okay, so now we have one fraction on the left, one fraction on the right. Now we can do our keep, change, flip. Okay, so I keep the first fraction just as it is, 2x plus 6 over 3x. I change the sign in the middle to multiplication, and I flip the second fraction, 3x over 5x plus 15. Okay, so now if you notice a few things. First thing I notice is this is multiplication, so I can start dividing things out that are exactly the same, but I can only do that for monomials unless things are factored. So first thing right off the bat I see is there's a 3x here and a 3x here, and since this is all multiplication, I can actually divide those out right away. Okay, so that leaves me with 2x plus 6 on the top and 5x plus 15 on the bottom. And I can't actually divide anything out unless it's factored. So I need to factor the top and bottom first. Okay, so in the top, I can take out a GCF of 2, and I get x plus 3 left. And then on the bottom, I can take a GCF of 5 out, and I get x plus 3. Awesome. So now if you notice, the top and bottom have that factor of x plus 3. I can divide these out, and I'm left with just 2 over 5. And there we go. Okay, guys, we just have one more example, so stay with me. Okay, last example here. So if you notice, now we have a lot of polynomials going on, and we have two fractions being added in the numerator and then just one fraction being divided in the denominator. Like I said, for the last two examples, first thing I'm going to do is rewrite this so that this division bar or this fraction bar, I'm going to rewrite it so it's a division symbol instead. So let's do that first. Okay, so the top here is, I'm going to move this over a little bit. There we go. The top, I'm going to put in parentheses, x over x minus 4, oops, there we go, plus 4 over x minus 10, and then divided by 5x plus 10 over x squared minus 14x plus 40. Sorry, it's a little cramped over there. Okay. So now I'm just going to work with the left side first, and I'm going to work on getting those two denominators to be exactly the same so that I can combine these two fractions. So this is what I'm going to work on first. Okay, so I see the denominator of the first fraction is x minus 4, and the denominator of the second fraction is x minus 10. So I need to make them look the same. I can't do this by adding or subtracting something. I can only do it by multiplication. So I basically just have to multiply each fraction by the other fraction's denominator. So, for example, the first fraction needs x minus 10. So I'm going to multiply that on the top and the bottom. And the second fraction needs x minus 4. So I'm going to multiply that on the top and the bottom. Okay, so now just to write it a little neater, I'll write it underneath, and I have x times x minus 10 over x minus 10 times x minus 4. And then the second fraction is 4 times x minus 4 over x minus 4 times x minus 10. Okay, so now I'm one step closer to combining these two fractions, and let's see, I'm going to distribute that x in on the first numerator. So I have x squared minus 10x, and over our common denominator. And then the second fraction, I'm going to multiply that 4 in, and I have 4x minus 16 over x minus 4 times x minus 10. Okay. going to combine them to one fraction since the denominators are the same. So since this is addition, we don't have to worry about like distributing the negative or anything like that. So I'm just going to rewrite all the numerators just together as one big numerator. And then I can combine like terms in the numerator there. Okay, so x squared, negative 10x plus 4x is negative 6x. So I have x squared minus 6x minus 16 over x minus 10, x minus 4. Cool. Okay, so then I need to look back at what was my denominator. So I had, this was the first fraction. So if you recall from up here, what we just did is we combine this stuff in here, and we got that one fraction that we were just working with, but then we still have divided by this fraction. So we need to bring that back. Okay. So I'm going to rewrite the division divided by, and then that second fraction is 5x plus 10 over x squared minus 14x plus 40. So now this is like the other day when we learned about division and multiplication of rational expressions. We just want to make sure everything is in fully factored form, and then we can divide out anything that's the same. Before we even do that though, let's change it, let's do the keep change flip to change it to multiplication. So the first fraction stays exactly the same. And the sign in the middle changes to multiplication, and then the second fraction flips. Okay, now we can start factoring and dividing out like terms or common factors. Okay, so first numerator, x squared minus 6x minus 16, we can factor that guy out to 16. Factors of 16 are 8 and 2, so that works, right? So okay, so the 8's going to be negative and the 2 is going to be positive. And then the bottom is x minus 10 over x minus 4, already factored out. Okay, and then the second numerator, I'm going to try to factor this guy out. So it needs to multiply to 40 and add to negative 14, so 10 and 4 should work. And it has to multiply to positive 40 and add to negative 14, so both of them are going to be negative. Okay, and then the bottom of the second fraction, 5x plus 10, I can take a 5 out, and that's x plus 2. Awesome, so now everything is just multiplication here, and everything's fully factored, so any common factors can be divided out. So I see x minus 10, x minus 10. I see x minus 4 and x minus 4. I see x plus 2 and x plus 2. And then I think that's it. So on the top, we're left with x minus 8. And on the bottom, we are just left with 5. Voila. Okay, guys, that's all for now.